Dear friends, today we will discuss one very important concept of current electricity, that is potentiometer. And this is a little bit tricky. So students generally face problem while solving the problem of potentiometer. So today let us discuss problem killer theory of potentiometer. Whenever you see the many books or any many questions in examination, you will find this type of circuit, sometimes this type of circuit. But do not worry to see difficult type of circuit. This circuit is actually very simple, and its simplest form can be written in this form. So this is the simplest circuit, and I recommend you to use this type of circuit whenever you solve the problem or try to understand the potentiometer question. Okay, so let us see the applications of potentiometer and its important result to solve the problem. So first of all, one of the important application of potentiometer is EMF comparison of two unknown cells. See, this is our main circuit. This is also called primary circuit, and this is primary cell, and this is a series resistance connected with primary cell, and AB is the length of potentiometer wire. And here E1 and E2 are two cells whose EMF need to compare. Okay, so suppose AB, the length of potentiometer wire is L. This end is called positive end. Okay, now suppose if we press this key and open this key, so this cell E1 is in circuit and E2 is out of the circuit, and in that case we just see the deflection of galvanometer by sliding the key over the potentiometer wire, and note the point where deflection of galvanometer is 0. Suppose that length become L1, that length is L1 from end A. Okay, now in second case, open this switch and close this switch and measure the length from end A. Again, suppose it is L2. Now the ratio of E1 and E2 will be equal to L1 by L2. E1 by E2 equal to L1 by L2. L1 by the length when cell E1 was in the circuit and deflection was found to 0. Okay. Similarly, L2 is the length when cell E2 was alone in the circuit. Okay. And corresponding length L2 was measured from end A. So this is the formula to compare the EMF of two unknown cell. Now potential gradient. What is potential gradient? This is also very important term, and many time in use you will see the problem. So potential gradient, basically it is the ratio of potential over length. Now suppose this is potentiometer wire, and if we take this total wire length AB, okay, then we have to find the potential drop across AB. Suppose this is VAB. You have given resistance of potentiometer wire and current in the primary circuit. From that you can find the voltage drop across potentiometer wire. Suppose that is VAB and their length is LAB. LAB is basically the total length of potentiometer wire. So we can write the potential gradient K is equal to VAB over LAB. Now this can also be written as VAC over LAC. Okay, so if you take length AB, then you have to, if you take length AB, then you have to find the potential drop across AB, and you have to divide with that length of potentiometer wire. Okay, now if you take suppose length AC, then you have to find the potential gradient across length AC, and you have to divide by that length AC. So it is not compulsory that we have to take length AB always. We can take any length, and then that length is divided, okay, by the potential what we find. So potential over length, potential by length, that is potential gradient. Now calculation of internal resistance is another main concept of potentiometer. Suppose this is our potentiometer circuit. This is again primary cell, resistance in series, and this is potentiometer wire. And this is positive end of the potentiometer wire. Now we have to find this resistance small r, that is internal resistance of the cell. Okay, this cell. This is the external cell we use to calculate. We have to find actually its internal resistance. Now what we do, we use one resistance in series, in parallel with this combination. Okay, say this is R1. Now this resistance R can be written as L1 by L2 minus 1 into R0. Here L1 is basically the length when this switch was open. L1 was the length when this switch was open, and L1 was measured from this positive end to that end. Okay. So L1 is the length when deflection in this galvanometer is 0 when this resistance was not in circuit. It means this switch was open. Take that length L1 and now press this switch, and now this resistance are not come in circuit, total circuit, and corresponding length is suppose L2. Okay. Then you have to take the ratio L1 over L2 minus 1 into R0. R0 is this resistance. So never confuse what is L1 and what is L2. Take bigger value in numerator and smaller value in denominator from your problem data. Okay. Now let us see one important application, one important special case of potentiometer problem. This is very important case and it is asked many times in previous year, JEE or NEET. You may find this type of problem. Okay. So let us see. This is again potentiometer circuit and AB is the potentiometer wire having length L. Now we have to calculate, suppose a small r, that is internal resistance of this cell, or this value or this value. See, let us see what are the function of this total circuit. So suppose this is a cell and whose internal resistance is R, and a resistance R1 and another resistance R2 is in parallel with this combination, this cell. So here it is switch S1 and here it is switch S2. Now suppose we close switch S1, okay, and then we measure potential difference across CD. Suppose that is VCD and that is V1. That is V1. Okay. That is V1, and corresponding deflection you have to find from galvanometer. Suppose V1 at when the potential difference across this terminal VCD is V1, then length from A is L1. Now again we close this switch and open this switch, and then we see the potential difference across this CD. Suppose this is V2, that will be E1 R2 by R1 R2 plus R. Now what we do, we use the EMF comparison concept, V1 over V2 equal to L1 over L2. Our V1 is E1 R1 by R1 plus R. This result you can find by applying Kirchhoff's voltage law in this circuit. When switch S1 is closed, just apply KVL in this circuit and get this result. That is voltage across CD. Now open this switch and close this switch and again apply Kirchhoff's voltage law and find voltage across CD. That is suppose V2, and you will get V2 equal to E1 R2 by R2 plus R. Then you have to use V1 by V2 equal to L1 by L2. Use this result here, V1 by V2 equal to L1 by L2. Now after taking the ratio, E1 cancel out, the result will be like this. Now you can see from this result, there are unknowns R2, R1, small r, L1, L2, and you have to find any one unknown at a time. Generally, R is the unknown. Generally, in most of the cases, you will face R. You have to find R, small r, and this value R2, R1, L1, L2 will be given in the question. So by using this expression, you can calculate the unknown small r, or sometime it may ask R2 or R1 or L1 or L2, etc. So it is very important concept when two resistances are connected in parallel with a cell whose internal resistance is R and EMF is E1. So it is better if you remember this result, and how this result come by using Kirchhoff's voltage law one by one. When switch S1 is closed, apply Kirchhoff's voltage law in this circuit, find the potential difference across CD, again open this switch and close this switch, again apply Kirchhoff's voltage law and again find potential difference across CD. In first case, potential difference across CD is taken as V1, and in second case taken as V2. V1 was this and V2 was this. Okay. After taking ratio using this expression, you will get this result. So this is very useful result, and it will definitely help you to solve question when you get some tricky question from potentiometer concept. Okay, so let us see in the next video. We will discuss more important concept. Thanks for watching.